Yeah, welcome to the new session of differential equations. So the previous sessions we started with the solutions of differential equations. So in that we had seen the variable separable method. So in this session we'll start with the homogeneous differential equation. Homogeneous differential equation. Homogeneous differential equations. Yeah. So a equation that is the first order and first degree differential equation like dy by dx, you know that first order and first degree differential equation dy by dx is equal to f of x comma y is said to be is said to be is said to be a homogeneous differential equation is said to be a homogeneous differential equation if f of x comma y if f of x comma y should be a homogeneous function of a degree 0 then I can call the function dy by dx as, that is f of x comma y, as homogeneous differential equation. So when I used to call the given differential equation as a homogeneous differential equation, it must be a homogeneous function of degree 0. So this I already explained you in the part of what do you mean by homogeneous function. Again, homogeneous function is nothing but what, ma? Yes or no? Homogeneous function means what? The order, that is a degree must be 0. So that means that the function, homogeneous function is what? That I already discussed you. That is homogeneous function means if I can able to write the function f of kx comma ky as what? K to the power of n into f of x comma y. If it is possible to write this, then I can call, if it is possible to write the function as f of kx comma ky as k to the power of n into f of x comma y, then f of x comma y is called as what, ma? Then f of x comma y is called as a homogeneous function. This I have already discussed in the part of your what? In the part of your what, ma? The calculus. That is partial derivatives and total differentiation. I just given you the definition. So let me take an example. So let me consider an example, ma, whether the given function is homogeneous or not. So that is, if I take a dy by dx, which is equivalent to what, ma? Suppose if I take a differential equation like this, x square plus y square by yx plus y square, if I take it as whether this function is homogeneous function or not, you need to check it out. Whether that is homogeneous or not, I need to check it out. So the function, which is nothing but what, which is equivalent to what? F of x comma y. So now let me take this f of x comma y will be, f of x comma y is nothing but what, ma? X square plus y square divided by yx plus y square. This is my f of x comma y. So now in order to check whether the given function f of x is homogeneous or not, I have to substitute in the place of x as a kx and y as what, ma? Ky I have to substitute it as. So suppose if I substitute here, what I'll get it as here? Check it out here. K x whole square plus ky whole square divided by ky into kx plus ky whole square. So in all those terms, if I take it as a k square as a common, I'll have here what? X square plus y square divided by this k into k square. Again k square will be there. Suppose if I take k square as a common, I'll have here what? Yx plus y square will be there. Am I correct or not? Yes or no? Yes. Yeah. So now that k will get k square will get cancelled. If it is getting cancelled, then I can go with respect to what, ma? This I can able to represent as what? This 2 will get cancelled. I can represent k power 0 into x square plus y square divided by yx plus y square I can represent it as. So now the function f of kx comma ky I represented here in the form of your k power 0 into x square plus y square by yx plus y square. So k power 0 into f of x comma y. Again this will be what ma? Your f of x comma y I just represented here. Am I right or not? So this is the part of this one. So if it is possible to write this in the form of this, I can call that as a homogeneous differential equation. Sorry, homogeneous function. Then when I can call that given function dy by dx as f of x comma y, which is homogeneous differential equation, it is a form of your what ma? Homogeneous function with a degree 0. Then I can call that as a homogeneous differential equation. Clear now? Understood what I'm saying here? Yeah. So now that means that no need to check always whether I need to substitute that kx, ky, not required ma. So just will compare with what the degrees. That's all. Nothing more than that. Suppose take a note point of here. Suppose if I'm mentioning the note point here, see mdx plus ndy, mdx plus ndy. This is also the first order, first degree differential equation. Mdx plus ndy is said to be a homogeneous differential equation. Is said to be a homogeneous differential equation if all the terms of capital M and N should be of same degree. Should be of same degree. That means mdx plus ndy is said to be a homogeneous differential equation if all the terms of m and n it should be a same degree. Then I can call directly. Same degree means what? See here, if you check it out, same degree means what? The given function f of x comma y is what? X square. So 2, y square 2. This is what? Y power 1, x power 1, 2 will be there. So all are what? The same degree. That's it. So that is the part of directly I can call that as a homogeneous differential equation. Clear now? Yeah. Next, one more point. Then how I can able to get the solution for this homogeneous differential equation? So usually if you are having such type of criteria, though every homogeneous function you can able to easily reduce in the form of your variable separable method. So that I will explain, you don't get bothered. So there will be substitution called as y is equal to vx. Earlier problem in the variable separable method you substituted what? Y is equal to vx. So where v is equal to y by x. So likewise you can able to do it as. So that is the part. Every homogeneous differential equation is reduced to variable separable form with the substitution y is equal to vx or x is equal to vy. These are the two substitutions which you have to keep in your mind. See, y is equal to vx, directly I can substitute it as, and the other one will be what? And the other one will be x is equal to vy. So these are the two substitutions. This you can do it as. Clear now? Right? Yeah, these are the two substitutions you can make it as. And then another point, last point which you have to keep in your mind is homogeneous function of a degree. Homogeneous function of a degree 0. Homogeneous function of a degree 0 can be written as a function of y by x or x by y, and with this substitution homogeneous homogeneous equation can be converted to variable separable form. So that is if I take an example, my earlier example only, dy by dx is equivalent to what? Some x square plus y square by yx plus y square. Yeah, the same example what you considered earlier, that example only I am considering here. So dy by dx is equal to x square plus y square by yx plus y square. So here what you can do is you can go with this is actually, if you observe here, it is a homogeneous differential equation because our degree all are same as it is. So now if I want to convert this in the form of your the variable separable method, what I will do is you can take x square as a common here. You can take x square as a common. See, from this, if I take x square as a common in that, you will have it as what? If I take x square as a common, what I will get it as 1 plus y square by x square divided by, again in this, x square, if I take it as a common, what I will get as here? Y by x. So this x will get cancelled, you will have yx. Then similarly, y square by x square. You can take y square also common, but for me, I am just taking that criteria. So this x square will get cancelled. What is the rest of the thing? 1 plus y square by x square divided by y by x plus y square by x square. Yeah, by seeing itself, you can substitute here what? By seeing itself, you can substitute here what? Y by x is equivalent to v, you can substitute it as. So now if you substitute this, you will have it as what? So 1 plus v square divided by v plus v square will be there. So from that, if you take the common as a v here, you will have what? 1 plus v will be there. Then you can go with the what? Again dy by dx. For this you have to go with what? Dy by dx, that and all. You can solve with the help of your what? The variable separable method. So what I am telling is, every homogeneous differential equation can be reduced into the variable separable method by the substitution of your what? Either taking y is equivalent to vx or x is equivalent to vy, you can substitute it as. That is how you people have to solve the questions based upon your homogeneous differential equation. Clear na? So that is the part of this one. So hence keep in your mind a homogeneous differential equation. Every homogeneous differential equation you can easily reduce in the form of your what? You can easily reduce into in the form of the variable separable method by making the substitution of what? By making the substitution of what? X is equivalent to vy or y is equivalent to vx. That you have to keep in your mind. So it's more than enough. Okay. So by default, homogeneous function means what? You can reduce this in the form of your the variable separable method. Either y is equivalent to vx or x is equivalent to vy. This you have to keep in your mind. That's it. Okay. Yeah. So let me start with one of the problem so that you people will have an idea. Solve the differential equation. Take an example for understanding this. Solve x into dy by dx is equivalent to y into log y minus log x plus 1. This is the question. You need to solve this one. Yeah, you have to solve this one. So if you check it properly, degrees all are same as it is. So x power 1, y, log x and 1. Yeah, degrees are same. That I can make it as what? The homogeneous differential equation. So now what I will get as here, check it out. What I will get? Yeah, simply what I will do is this x if I take that side. So what I will get? Check it out, dy by dx is equivalent to y by x, then log a minus log b. Again you will have it as what? Log of y by x plus 1. Am I right or not? Yeah. So by seeing itself, you can put y by x is equivalent to v. So let y by x is equivalent to v, you people have it as. So that is, you will have what? y is equivalent to vx. Yeah, for this, what is the differentiation? Y is equivalent to vx means what? Differentiation. Y is equal to vx is nothing but what? Do that this one dy by dx, as I already given you in the variable subproblem method. So v with respect to x, v plus, then again x into, for v you will have it as what? Dv by dx. uv rule you have to perform it as. So now dy by dx is v plus x into dv by dx. So now replace all these things in this. Replace dy by dx is nothing but what? V plus x into dv by dx, which is equivalent to y by x is what? V into log v plus 1. Am I correct or not? Yeah. So v plus x dv by, just after this you go with what? The simple substitutions. So v log v plus v will be there. So if you observe properly, this v will gets cancelled. Then the rest of the thing will be what? Rest will be what? From this you can go dv divided by what? V log v, which is equivalent to what? X into, sorry, yeah, that will be there. So dx by x will be there. Am I correct or not? Yeah. So I'll go with do the different, integration. So now I just separated the variable separable method. Am I right or not? So just from here you go with what? The integration. That's all. So again, if I want to make that integration for this, what I will do is I will substitute log v is some other variable t if I substitute as. Then what is the differentiation here? 1 by v dv is equivalent to what? Dt. So now 1 by v dv is equivalent to what? Dt I can substitute as. So now substitute this. Simple. After this it will be what? Your integration part. That's all. So integral 1 by t into dt, which is equivalent to what? 1 by x into dx will be there. So that you know that integral 1 by t will be what? Log t. Am I right or not? So log t or ln t, which is equivalent to log x plus what? Log c will be there. Right? Yeah, this again log t is equivalent to log x c, you can represent it as. Then both sides log will cancel. T is equivalent to what? Cx you will have it as. Then what is your t there? What is your t? T is nothing but what? Log v. Again v is nothing but what? Y by x. First let me substitute this. T will be, t is log v, which is equivalent to c into x. Right? Then from this, what is your y v? From this v is equivalent to what? From this v is equivalent to what? This log goes to that side, e to the power of cx. Again what is your v? V is equivalent to what? Y by x. That also you substitute it as. So which is y by x is equivalent to e to the power of cx. Then y is equivalent to what? X e to the power of cx. X e to the power of cx. This is the part of your solution. That's all. So you can solve any number of problems based upon this analysis. Okay, getting what I'm saying here? Yeah. So likewise you can able to solve the problem based upon your homogeneous differential equation. Okay, getting what I'm saying? Getting what I'm saying? Yeah. So till now there is no question, but still I'm just given you what the ideology about the homogeneous differential equation. Okay. Yeah. So every problem there will be substitution called as either y is equivalent to vx or x is equivalent to vy. Any of the substitution you can do it as. Clear? Yeah. You can solve based upon that criteria. Okay. Yeah. Next I'll go with the another one, which is called as a non-homogeneous differential equation. Next one. Non-homogeneous differential equation. Next one will be non-homogeneous differential equation. Yeah, actually the non-homogeneous differential equation, which will be in the form of called as dy by dx. Dy by dx is equivalent to a1x plus b1y plus c1 divided by a2x plus b2y plus c2 will be there. This is the non-homogeneous differential equation. Then how I can able to get the solution? So variable separable method, directly you can separate the x terms as well as your y terms. That directly are done. Then homogeneous also, every homogeneous function can be reduced in the form of your variable separable method by the substitution of y is equal to vx or x is equivalent to vy. You can do it as. But when it comes to the part of your non-homogeneous system of linear equations, sorry, non-homogeneous differential equations, the form will be like this. So then how I can able to get the solution? So here there will be two solutions. I mean the way of solving this non-homogeneous differential equation is there are two different solutions will be there. One is the first case. Let me take the first case. So if in this case, if see that coefficients a1 and a1 b1 c1 a2 b2 c2 all are what the coefficients. If a1 by a2 which is equivalent to b1 by b2, if a1 by a2 is equivalent to b1 by b2, if it happens, then if a1 by a2 is equivalent to b1 by b2, then there exists, if it is such a case, then there exists a substitution, then there exists a substitution which reduces the given equation, the given differential equation to the variable separable method. Variable separable method. This is the first case. See, if a1 by a2, if a1 by a2 is equivalent to b1 by b2, then there will be existing of what? Then there exists a substitution which reduces the given differential equation into the variable separable method. Once if it is a variable separable method, then you can go with what? The analysis. Am I right or not? So let me take an example. For that you can have an idea. So let me take an example here. The example is solve 2x plus 2y minus 1 into dx is equivalent to x plus y plus 1 into dy. Solve 2x plus 2y minus 1 into dx is equivalent to x plus y plus 1 into dy. You have to do it as. So how I will solve it? How I will solve it as, let me consider dy by dx here. What will get us here? Dy by dx is nothing but what? Dy by dx is what? 2x plus 2y minus 1 divided by x plus y plus 1. So you just compare this with respect to your what? What is your normal equation? a1x plus b1y plus c1 divided by a2x plus b2y plus c2 will be the the non-homogeneous thing. So now what is the values are here? A1 is equivalent to what? 2. Just try to compare this one. Next b1 is equivalent to 2. Then similarly a2 is equivalent to 1. Then b2 is equivalent to what? b2 is equivalent to 1. So now you have to check it out what? If a1 by a2 is equivalent to b1 by b2, then you can, there will be substitution method called as. So that is, take down a1 by a2 which is equivalent to b1 by b2 or not. Check it out. What is this? A1 by a2 is what? 2 by 1 which is equivalent to 2 by 1. So hence it satisfies this condition or not? 2 is equivalent to 2 it satisfies. Am I correct or not? So there will be a existence of what? The substitution method. So try to check it out. The differential equation dy by dx. See the given differential equation. What I will do is I will just make it as 2 as a common. If I take 2 is a common, 2 into x plus y minus 1. Then this one will be what? X plus y plus 1 I have to take it as. Am I correct or not? So now let me take the substitution called as what? Let that x plus y will be another variable. So let x plus y is equivalent to v. Do the differentiation 1 plus dy by dx. With respect to x I am doing the differentiation. So you will have it as dv by dx. Now substitute that what I will get as from this dy by dx is what? Dy by dx is nothing but what? dv by dx minus 1 will be there. Am I right or not? So substitute this dy by dx. In that what I will get as here, check it out. What I will get? Dy by dx is nothing but what? dv by dx minus 1 which is equivalent to 2v minus 1 by v plus 1. Am I correct? Am I correct or not? Yes or no? Yeah. So what I'll get as here again, this one I will take it at that side. So dv by dx is equivalent to 2v minus 1 by v plus 1. That minus 1 goes to that side plus 1. Yeah, you will have here what? 2v minus 1 LCM take it as plus v plus 1 divided by v plus 1 will be there. So do that simplification, dv by dx. Yeah, what will get us here? Dv by dx is equal to what ma? 2v means 3v divided by v plus 1. So this minus 1 plus 1 will get cancelled. 3v by v plus 1. Then again it is in the form of your v and x. You can go with the variable separable method. So do that variable separable method. What I'll get as here? V plus 1 divided by the 3 I will keep same at side. So by this is dv which is equal to what ma? 3 into dx. So now I'll go with what? The integration. So if I apply the integration, I'll have it as what? Yeah, integration means what ma? Again this vv will be what ma? 1 plus 1 by v. So directly if I do the integration, I'll have it as what? V plus log v which is equal to what? 3x plus c will be there. Yeah, then how I can able to do it as? What is your v here? This is actually the solution for the variable separable method. Am I correct or not? So you know v is equal to what? X plus y. I just substituted. So just substitute that v as what ma? X plus y plus log of x plus y which is equal to what? 3x plus c. Then again you can simplify it as ma. This x will be there, that if I take this side, so minus 3x will be there, minus 3x plus x minus 2x. So directly you can go with as what? Y minus 2x plus log of x plus y which is equivalent to c. I can do it as. So this is the final solution for the corresponding thing. So when this case will be existing ma, the case 1 will be what? If a1 by a2 is equivalent to b1 by b2, then they are existing of what? If a1 by a2 is equivalent to b1 by b2, then there exists what ma? The substitution method called as this one. Clear na? Getting what I'm saying here? Understanding what I'm saying here? Yeah. Sometimes that a1 by a2 is not equivalent to b1 by b2 ma. At the time what you people have to do it as? At the time what you have to do it as? Check it out again. So if it is not possible, it is not possible. So hence see ma, they won't ask you the questions like this because for understanding this, I'm just giving the ideology. That's all, nothing more than that. So what are the different types of methods you are having? Right. So maximum they will concentrate the questions, that is the solutions on the this is one is the variable separable method, and the other one will be what? Next one will be exact and non-exact. Then one more will be what ma? The linear equations. Maximum questions they will try to concentrate on those three topics. But these also I'm just giving an idea. Am I right or not? So maybe you studied in your academics these criteria. But for knowing that purpose, I'm just giving the methods here. Okay. So try to consider the case 2 here. If a1 by a2 is not equivalent to b1 by b2. Case 2 if I consider it as, yeah, what is that case 2 I'm considering here? If a1 by a2 is not equivalent to b1 by b2. If a1 by a2 is not equivalent to b1 by b2, then what you people have to do it as? Then assume small x as capital X plus h and small y as capital Y plus k. I have to assume it as. These two you people have to assume and you have to continue with that process. Am I right or not? Yeah, what will get it as here? See, if I assume this one, let me take, see, my differential equation is nothing but what? Dy by dx is equal to what ma? Usually dy by dx is equal to what? a1x plus b1y plus c1 divided by a2x plus b2y plus c2. Right. Okay. So what I told here, let you have to take it as what? My x is equivalent to capital X plus h and small y is equivalent to capital Y plus k. I have to do it as. So now the differentiation, do the differentiation. Dx is equivalent to what ma? With respect to x I am doing. So capital Dx. For h it is a constant, that is directly 0. Then y, dy is equivalent to what? Capital D y. Am I right or not? For k it's a constant 0. So now substitute these things. What will get it as? If I substitute all these, so capital dx divided by, sorry, dy na? Yeah, dy divided by dx, which is equivalent to a1 into x means what ma? X plus h plus b1 into y plus k plus c1 will be there, divided by again a2 into x plus h plus b2 into y plus k plus c2 will be there. Am I correct? Am I correct or wrong? Yeah, that is how it will be there. So now I will just multiply these things. This is just a method, that's all, nothing more than that. So a1x plus a1h plus b1y plus b1k plus c1 divided by a2x plus a2h plus b2y plus b2k plus c2. Yeah, x terms one side and constants one side I will represent as. So that is a1x plus b1y plus a1h plus b1k plus c1, right, divided by, similar to the earlier case, a2x plus b2y plus a2h plus b2k plus c2 will be there. So this is what the particular analysis. Okay, yeah, now what I will do is, if you observe properly, if you observe a1h plus b1k plus c1, a2h plus b2k plus c2. So these two things I will make it as 0. These two things I will make it as 0. If I make that two things as a 0, what I will get as here? Yes. So you need to choose why I will get, how I will get as, you can ask a doubt, sir, how I will get, how I will make that h and k, I mean these two, three terms, how you are making it as a 0. So you need to choose h comma k, so that you need to choose h comma k, so that a1h plus b1k plus c1 is equal to 0. Similarly, a2h plus b2k plus c2 is equal to 0. In such a way that you have to choose your values of your h and k. So if I make that is equal to 0, then what I will get as here? If this it is 0, you will have it as what? dy by dx, which is equal to what? a1x plus b1y divided by what? a2x plus b2y will be there. So now if you check it properly, again this is nothing but what? The conversion of your non-homogeneous differential equation into homogeneous differential equation. Now you will have a1 by a2 is equal to what? b1 by b2 will be. Obviously you will have it as the thing. So far whatever the analysis you've done is, for making a1 by a2 is not equal to b1 by b2 into a1 by a2 is equal to b1 by b2. So after making this, again you will have it as what? The conversion. So either y is equal to vx or what? X is equal to vy. Then you can go with the solution. That's all, nothing more than that. So here, in order to get the solution with respect to your the non-homogeneous differential equation in the second case, that is a1 by a2 is not equal to b1 by b2. First, let me consider, I will convert that non-homogeneous differential equation into what? That is the first case. Second case into first case I will convert it as. If it is converted into the first case, then there will be a form of what? You can able to easily reduce that into what? The variable separable method. You can have the solution. Okay, so till now there is no question based upon that, but still if it is having a question, you can approach this method. That's all, nothing more important here. Clear now? Clear with my point? Yeah. So this is a lengthy procedure, so that is the reason why they won't ask you these questions. Okay. Yeah. For understanding, let me take one of the previous, what I can say that not in GATE, it is an IES question. Let me consider this case. Okay, let me consider that case. How you people have to select the values of your h and k, I'll just explain you here. Okay, yeah, take down the question. Yeah, take down the question. Which of the following substitution which of the following substitutions reduces the non-homogeneous differential equation? Non-homogeneous differential equation dy by dx is equivalent to y plus x minus 2 divided by y minus x minus 4 to homogeneous form. homogeneous form. Yeah, this is the question they asked. Simply they asked what is which of the following substitutions reduces the non-homogeneous differential equation into homogeneous form. So that is dy by dx is equal to y plus x minus 2. They are asking. Am I right or not? So generally the question what you people do it as, generally that question will be what ma solved by what? Actually this is what a1 by a2 is equivalent to b1 by b2. No. What is that? A1 is 1, B1 is 1, A2 is 1 and B2 is what? Minus 1. So A1 by A2 is not equivalent to B1 by B2. So this is the non-homogeneous differential equation second case. So in that what you people have to do it as, you need to make a substitution of what? Small x is equivalent to x plus h and y is equivalent to capital Y plus k. That is what the substitution people have to do it as. So x is equivalent to, though you check it out here, A1 by A2 is not equivalent to B1 by B2. So it is a non-homogeneous differential equation second case. That is A1 is 1, B1 is, A2 is what? 1. But B1 is 1 and B2 is minus 1. So these two are not equal. So I will take it as what? X is equivalent to capital X plus H and Y is equivalent to what? Capital Y plus K. I have to substitute it as. Am I right or not? Yes or no? Yeah. So now what I'll do is, see this y plus x minus 2, y minus x minus 4. Usually a1 x is equal to x plus h, y is equal to y plus k. I need to substitute as, then I have to do this one. So now simple criteria, y plus x minus 2 is equal to 0. Then similarly what? Y minus x is minus 4, which is equal to 0. Yeah. What is this exactly replica of this one? Y plus x minus 2 means what? Y is, see in the form of y is k you are having, x we will have h. So hence k plus h minus 2 is equal to 0. Then k minus h minus 4 is equal to 0. I just simply replaced x and y. Y has k, x has h. I just simply replace it as. Am I right or not? Yeah. So now if I add these two things, I'll have the value of your what? So these two will get cancelled. Then the value 2k is equal to 6. So k is equivalent to what 3. Yeah. Once if I have the value of my k, if I substitute any one of this, I'll get what? The value of your h also. So that is 3 plus h minus 2 is equal to 0. So h is equivalent to what minus 1 will be there. So now the value of your h comma k will be what? H comma k is what? H is minus 1 and k is what 3. So now just substitute. Which substitution you people have it as? So substitution means what? X is equivalent to capital X plus h and y is equivalent to what? Capital Y plus k you people have it as. So now substitute this one. This is what the substitution I have to do it as. So you know the value of this one. So x is equivalent to what capital X, h is what? Minus 1. Then similarly y is equivalent to what? Y, k is 3. So simple this one. So substitute x as x minus 1 and y as y plus 3. So then that non-homogeneous differential equation is converted in the form of your what? Homogeneous differential equation. That's all. It is a homogeneous form. That's it. Nothing more than here. Clear with my point? Getting what I'm saying here? Yes or no? Yeah. So that is how they will ask you the questions based upon your what? The non-homogeneous differential equations. Clear? I hope you are understanding these criteria. So there is no other question based upon your non-homogeneous differential equation. Yeah. Next other one, you'll go with the exact differential equation. Again, this is also very important criteria. Yeah. Let me consider that exact differential equation. Next one. Next method. Next method will be exact differential equation. Next method will be the exact differential equation. Yeah. So when I can call the given differential equation as what? Exact differential equation. So a differential equation, let me take a differential equation mdx plus ndy is equal to 0 is said to be exact if there exists at least that is f of x comma y such that if there exists f of x comma y such that differentiation of f of x comma y is equivalent to differentiation of f of x comma y is equivalent to mdx plus ndy. Differentiation of f of x comma y is equivalent to mdx plus ndy. Then I can call that mdx plus ndy as a exact differential equation. So take an example so that you people will have an idea. So take an example as y square dx plus 2xy y square dx plus 2xy dy is equivalent to 0. So this you take it as what ma? The mdx plus ndy. So just try to compare. This is your mdx. This is your what ma? N dy. So sorry, and this is what your n mdx plus n dy is equal to 0. Am I right or not? See, if you take this as try to take the differentiation of this will be like y square into x ma. So just I'm assuming this as differentiation of y square into x. So UV rule you apply it as what will you get as here? UV rule. So differentiation of y square into dx will be what ma? Y square into dx plus what? Then 2xy into dy. Am I right or not? Same as it is of this one. So what I'm telling is the given mdx plus ndy, if I can able to write in the form of your differentiation of your y f of x comma y, then I can call that mdx plus ndy as what ma? Exact differential equation. Exact differential equation. Then if it is exact differential equation, then how I can able to get the solution? So actually one of the theorem is there. Maybe exact means by default you people will have a remembrance of what ma? Dou n by dou x is equal to, sorry, dou n by dou y is equal to dou n by dou x. You people will do it as. So that is actually a theorem. So that theorem you take it as. So usually you will check with that that only. So the theorem will be take it out. That theorem will be what ma? The differential equation mdx plus ndy mdx plus ndy is equal to 0 is exact if and only if dou m by dou y is equal to dou n by dou x. Dou m by dou y is equal to, yeah, if it satisfies this condition, I can call the given differential equation as what ma? Exact differential equation. Yeah, if it is exact differential equation, then how I can able to get the solution? So let me consider that also. Yeah, if I take the differential equation is mdx plus ndy is equal to 0. This is a differential equation ma. If it is exact, exact differential equation, that means what? Exact differential equation is nothing but what ma? You need to check with the what? Dou m by dou y is equal to what? Dou n by dou x. This is exact differential equation. Yeah, then what is the solution for this? The solution will be what? If it is exact differential equation, solution will be integral mdx where you have to consider it as what ma? Y as constant. In that whatever the values of your m you are having, in that y you people have to treat it as what ma? Y as constant. Then plus integral n into dy which is equivalent to c ma. Here also you have to consider it as what? The terms of n you have to choose it as what? Without x. Terms not containing x ma. This you have to consider it as. I will explain you, don't get bothered. Terms not containing x. So while treating the value of your m integration, y as a constant, and the terms you are choosing with respect to n, those terms should not contain x. So this is the solution of exact differential equation. This is the solution of your what ma? Exact differential equation. Clear na? Getting what I'm saying here? Yeah, that is what the part of your the thing. Then how I can able to get the solution? So let me take an example. So that you will have an idea how it is happens. How these criteria are happening. Okay. Yeah, I will make a solution. You don't get bothered. Clear what I'm saying? Yeah, let me take an example. Find a P so that py dx minus of 1 plus sine square y, 1 plus sine square y plus cos square x into dy is equivalent to 0 is exact differential equation. Is exact. Find the p so that p into y dx minus of 1 plus sine square y plus cos square x dy is equivalent to 0 is exact differential equation. Right? Yeah. Yes. So how I will solve this one? Yes, ma. How I will solve it as? They are asking what? They itself in the problem itself they told you what, ma? It is exact differential equation. Then what is the value of your p? So m dx plus n dy. So what is your m dx here? M will be what, ma? Py, and n will be what? This one. So this is m dx plus n dy. So m is equivalent to, you will have a py, and n is equivalent to what? Minus of 1 plus sine square y plus cos square x will be there. So this is the value of your m and n. Right. So if it is exact means dou m by dou y is equivalent to dou n by dou x. So let me calculate that. Let me calculate this one. Dou m by dou y is nothing but what? With respect to y only you are having. This is a p. Then dou n by dou x you do it as dou n by dou x you will have it as what? With respect to x only I have to substitute as. So that is minus of 0 plus this is also 0. Then you will have it as what? Plus 2 into cos x. 2 into cos x, again for cos x you will have it as what, ma? Minus sin x will be there. Am I correct or not? Yeah, this is the part of this one. Am I correct or not? Yeah, again check it out. Minus 2 sin x cos x, ma. This minus of minus plus will be there. You will have it as what? Sin 2x will be there. So if these two are equal, so they are given what, ma? Exact differential equation. So in the problem itself they given you it as exact differential equation. They given it as what, ma? Exact differential equation. If it is exact differential equation, you will have it as what? Dou m by dou y is equivalent to what? Dou n by dou x. So dou m by dou y is equivalent to dou n by dou x. So just substitute this one. So if these two things are equal, then what is the value of your p, ma? So these two are equal. This is the part of this one. So p and this one. So hence the value of your p is nothing but what, ma? Hence the value of your p is nothing but what? Dou m by dou y is p. Dou n by dou x is what? Sin 2x. So that is p is equivalent to sin 2x. You people have it as. Clear, ma? Understood or not? Yeah, p is equivalent to sin 2x. You will do it as. That is the part of this one. Clear? Yeah. So that is how you have to solve it as. Next. One more problem. Next problem, ma? Yeah. 3a square x square plus by cos x into dx plus 2 sin x minus 4ay cube into dy is equal to 0 is exact then a and b's they given the options as exactness depends on both a and b. Exactness depends on both a and b. Option B, exactness depends only on a. Option C, exactness depends only on B. Option D, exactness not depends on both A and B. Exactness not depends on both A and B. So this is the question. So what they are asking? What is the thing you people have to keep in your mind? What's the thing here? Check it out properly here. What you will get as? Yes? Yeah, tell me. Just try to take dou m by dou y and dou n by dou x, ma. The given differential equation is what? M dx. So this is your m, this is your what, ma? N. So m dx plus n dy. So let me take m and n. So if I consider that particular solution here, the value of your m is what, ma? m is nothing but what? 3a square x square plus by into cos x. This is your m, and n will be what? N is nothing but what? 2 sin x minus 4ay cube is your n. Am I right or not? Yeah. So here for this you take a dou m by dou y. What is your dou m by dou y with respect to y? I need to do test. So this is what? Minus b into sin x. This is your what? Dou m by dou y. Sorry, with respect to y you have to do it now. No x. Sorry, I done a mistake here. Yeah, b into cos x you will have it as with respect to y only. So for y only one is a differentiation. Yeah, next dou n by dou x with respect to x I have to do it as. So that is what x means what? 2 cos x. That's all. So if it is exact, so dou m by dou y which is equivalent to what? Dou n by dou x. If it is exact differential equation, then you can go do it as. So which is nothing but what? B cos x is equivalent to 2 cos x. So b is equivalent to what? 2. That means your exactness depends only on what? B or not? Yes or no? So exactness depends only on what? Exactness depends only on what? B. Exactness depends only on B. So that is the option C is the right answer. Clear? Yeah, that is the part of that one. Next problem. Solve ax plus hy plus g into dx plus hx plus by plus f into dy is equal to 0. Yeah, see it is in the form of your mdx plus ndy. Mdx plus ndy will be there. So whether this given function is homogeneous, exact or non-exact, you can check it out. So this is your m, this is your n. So let me calculate dou m by dou x and dou n by dou y. So what is your dou m by dou y? With respect to y only I am doing it as. So dou m by dou y is what h. Similarly dou n by dou x is what? Dou n by dou x is what with respect to x. So you will have it as h. So dou m by dou y is equivalent to dou n by dou x. So hence this is what? This is what exact differential equation. Am I right or not? Yeah, if it is exact differential equation solution, what you have to do it as? What do people have to do it as? Solution will be what if it is this one, the solution will be what? Integral mdx plus integral ndy is equal to constant. So where here y as a constant and here terms not containing x. This is the solution of your what? The exact differential equation. Am I correct or not? Yeah. So terms not containing. Check it out. Terms not containing x means what? See, total integral m dx means m. Every m people have to take it as ax plus hy plus g into dx. Right. Then plus. See directly while doing this integration here, y you have to treat this as a constant. But here comes to the part of this one. Terms not containing x. Yeah. See, check it out here. This terms not containing x means what? Hx, x will be there, not required. Then remaining will be what? Terms not containing x. So hence you will have it as what? By plus f into dy, which is equivalent to constant. So for this, you people have to do the integration. That's all. Nothing more than that. So do the integration for this. What will get as here? Integration a into with respect to x only, so x square by 2. Then h into what? H into y integration. So with respect to you have to treat that as what? X as a constant. Sorry, y as a constant. So hence you will have x plus g x plus you will have b y square by 2 plus f into y, which is equivalent to 6. This is the solution for the corresponding differential equation. This is the solution for the corresponding differential equation. That is how you people have to solve it as. But my point, yeah, can you try one more problem based upon this exact differential equation? Yeah, can you try one more problem based upon this? Solve y into 1 plus 1 by x plus cos y into dx plus x plus log x minus x sin y into dy, which is equivalent to 0. This is the question. Try to solve this. Yeah, solve this. So how you people will solve this question, ma? Again, if you see here, this is your m and this is your what? N. So mdx plus ndy here you are having. So again, calculate dou m by dou y and dou n by dou x. Whether it is a exact equation, then you will have a solution, right? So try to check it out. Dou m by dou y is what? With respect to y, you people have to do it as. So y means what, ma? Yeah, 1 plus 1 by x plus for cos y you will have it as what? Minus sin y. This is dou m by dou y. Then dou n by dou x. For x you will have 1 plus for log x you will have 1 by x minus for x you will have sin y. So dou m by dou y is equivalent to what, ma? Dou n by dou x. So it is a exact differential equation. So if it is exact differential equation, what will be the solution? Integral m into dx where y as a constant plus n into dy, the terms not containing x, right? So solution will be what, ma? What is that solution? So integral m dx. So m will be what, ma? What will I have it as? Y into 1 plus 1 by x plus cos y into dy plus integral n, the terms not containing x. So if you check it, the given equation, terms not containing x. So all terms are having what, ma? X terms. So hence dy, n, you don't have any criteria. So this is 0. You will have it as the constant c. So for this you have to get the solution. So what's the solution here you are having? So y, you people have to treat y as what, ma? You have to treat it as, here it is x, na? This is dx, mdx plus ndy. Yeah, you need to treat y as a constant. So y into, yeah, for 1 you will have x plus for 1 by x, which is nothing but what, ma? Log x plus cos y into x, which is equivalent to constant c. So simply again, if I write this, you will have it as what? You will have it as what, ma? Xy plus y log x plus x cos y is equivalent to c. So this is the solution for the corresponding exact differential equation. Clear? Yes or no? Yeah. So that is a part of that one. Next problem. So that people have to solve the problems based upon the exact differential equations like that. Next one will be solve y dx minus x dy is equivalent to 0. Y dx minus x dy is equivalent to 0. Yeah. How you people will solve this one? Again, how you will solve it? Yes, ma. How you will solve it as? If you observe here, again, this is your m dx plus n dy. This is your n. So m will be what, ma? Y, and n will be what? Minus x. Yeah, dou m by dou y is what? Dou m by dou y is 1, and dou n by dou x is what? Minus 1. So that is dou m by dou y is not equivalent to dou n by dou x. So it is not exact. It is not exact differential equation. Am I correct or not? It is not a exact differential equation. Clear, na? It is not exact differential equation. Am I correct? Yeah. So if it is not exact differential equation, then how you people have to do it as? Here it plays a major role, the concept of integrating factor, ma. So the concept of integrating factor, what do you mean by that is simply, first let me give you the solution for this, then I will explain you the concept of your integrating factor. So multiply that equation, see this, you take it as equation 1, if you take it as multiply equation 1 with what? 1 by y square, ma. So try to check it out. If you multiply that equation 1 with 1 by y square, what you will have it as? 1 by y square into y dx minus x into 1 by y square dy is equivalent to 0. Yeah. So now what I'll have it as 1 by y into dx minus x by y square into dy is equivalent to 0. So now this is the equation. Am I right or not? So take this as equation 2. Similar approach. Try to do that. So take this as m dx plus n dy. This is m. This is n. So what is your m here? M is 1 by y and n is what? Minus x by y square. So again dou m by dou y. Dou m by dou y. What is the differentiation for 1 by y? UV rule. You will have it as what? Minus 1 by y square. Then similarly dou n by dou x. Yeah. Dou n by dou x minus 1 by y square is a constant, and for x you will have it as what? 1. So now in this case, dou m by dou y is equal to dou n by dou x or not? This is exact equation or not? So dou m by dou y is equal to dou n by dou x. So this is exact differential equation. Am I correct or not? Yeah. If it is exact differential equation, then you have to go with respect to what? The solution for this. Yeah. What is the solution for this? What is the solution for this? Yes. Yeah. The solution will be integral m dx. So where y as a constant. Am I correct or not? Yeah. So integral m dx. So that is what you people have it as. Check it out here. Integral m dx means what? 1 by y into dx plus integral terms not containing. So you don't have any things. So this is dy which is equivalent to c. So what is the solution here? What is the solution here? 1 by y will be what? Log y which is equivalent to c. This is the solution for the corresponding differential equation. So here if dou m by dou y is not equivalent to dou n by dou x, if dou m by dou y is not equivalent to dou n by dou x, in that case I can call that is a non-exact differential equation. That non-exact differential equation will be converted into the exact differential equation by making a multiplying factor. That multiplying factor itself I am calling it as what? Integrating factor. Itself I am calling it as integrating factor. This itself I am calling it as what? The integrating factor. Getting what I am saying here? Yeah. So let me take the point here. Integrating factor. What do you mean by the integrating factor? It is a multiplying factor only, which is used for what? Converting a non-exact differential equation into exact differential equation. So that you note it down. A non-exact equation, a non-exact differential equation, a non-exact differential equation is converted into a non-exact differential equation is converted to exact differential equation by multiplying with the functions, by multiplying with the functions, by multiplying with the function, that is f of x comma y, by multiplying with the function f of x comma y, then that f of x comma y is called as, then that f of x comma y is called as what? Integrating factor. Integrating factor. That f of x comma y I used to call it as what? The integrating factor. Clear now? That's all. Am I right or not? So this is the part of that criteria. So that means here a non-exact differential equation is converted into exact differential equation. How will convert that? We will multiply with a factor, that is a function. That function will multiply with some f of x comma y. So earlier in this problem we multiplied with what? 1 by y square. This 1 by y square I used to call it as what? This 1 by y square. This 1 by y square I used to call it as what? The integrating factor. So likewise you people will have different types of integrating factor. You people will have the different types of integrating factor will be there. So that is you used to take some examples. Examples are integrating factor examples. Integrating factor examples are, you will have what? Like 1 by y square, 1 by x square, and 1 by xy, and 1 by x square plus y square, and so on. So likewise, things you people will have it as the integrating factor. Clear now? So here you have to make a note point. I'll explain you. Yeah. So you people will have a doubt that. So which case, what the thing I have to use it as. So that is how you people will have a doubt that. So let me take a note point here, ma. Actually, suppose if I take the equation like this. So this is what I can say that m dx plus n dy, which is equivalent to 0 if it is a non-exact. If it is non-exact differential equation, non-exact means what? Dou m by dou y is not equivalent to dou m by dou y is not equivalent to dou n by dou x. This is a non-exact differential equation. So if it is that case, then what will happen? So you people will have different cases more. You people will have a different cases. So if it is a non-exact differential equation, what you people have to consider here is, if it is this case, the case 1 will be the solution. Case 1 will be, try to take it as all the terms in the case 1, all the terms of capital M and N, all the terms of capital M and N should be, there are different approaches, like 5 different approaches will be there. So all the terms of M and N should be of a same degree, then my integrating factor IF will be, IF is integrating factor I used to represent it as. Here itself you represent this one, IF will be the integrating factor. Okay, yeah. So my IF will be 1 by mx plus ny will be the integrating factor. If all the terms of m and n in the given equation it is containing the same degree, then my integrating factor will be 1 by mx plus ny. Similarly, the case 2, there are different cases will be there. That different cases we will study it as. Here provided that you just take it as provided that my mx plus ny it should not be equivalent to 0. It is not equivalent to 0. If it is 0 means there is no meaning of that one. So that is the reason why. Yeah. Next case 2, if I take it as, if I take a case 2, in the case 2, the equation is of the form, y into f of x comma y into dx plus x into g of x comma y dy if I am having. The equation is of the form which is equivalent to 0. Then my IF will be, integrating factor will be 1 by mx minus n into y. So provided that mx minus ny it should not be equivalent to 0. So this is another factor. See, the case 1 will be what if m and n are for the same degree, then my integrating factor will be 1 by mx plus ny. If the given equation is of the form y into f of x comma y dx plus x into g of x comma y dy if we are having, then that will be nothing but what? Yes, that should be what? 1 by mx minus ny I have to consider it as. Clear na? Yeah, this is a case 2. Next case 3. If I go with the case 3, here the case 3, dou m by dou y minus dou n by dou x divided by n, which is equivalent to the function f of x, or sometimes it may be a constant also. If it is in the form, then my integrating factor is what? Integrating factor is e to the power of integral f of x into dx. This is the integrating factor. Don't get confused. I'll give the idea. Sir, when I have to take it as a dou m by dou y minus dou n by dou x, like that you people have a doubt. I'll just give you the justification for both case 3 and case 4 because it is those two are similar cases. So case 4, if I take it as, the case 4 will be just similar to your case 3 only. Yeah, here I can take it as dou n by dou x minus dou m by dou y divided by m, which is equal to some function g of y, or sometimes it may be a constant. sometimes it may be a constant. In that case, my integrating factor is similar to your e to the power of integral g of y into dy. Integral g of y into dy. This is the part of that criteria. Getting what I'm saying here? Getting what I'm saying here? Yeah, this is the part of that. Here you have a doubt, sir, when I have to use dou m by dou y minus dou n by dou x by n and dou n by dou x minus dou m by dou y by m is that function. So in the given function m dx plus n dy it is there. So in the given function m dx plus n dy, if m terms contains more means dou m by dou y minus dou n by dou x. If n terms contains more means you have to subtract n with m. That's all. This is only the simple strategy what you have to keep in your mind. See, in the function C, if I take m dx plus n dy, if we are having, this is a differential equation which is equivalent to 0. If m is containing more terms means the first case. Am I right or not? This is the first case. Then the case 4 means if n contains more terms. If n contains more terms means you have to go with these conditions. That's all. Nothing more complication here. See, if m contains more, dou m by dou y minus dou n by dou x. If n contains more, dou n by dou x minus dou m by dou y. That's all. Based upon that, you will write it as what? The integrating factor. And the last one, the case 5 will be what, ma? The case 5 will be the inspection method. That I will explain you with the respective topic. So, which is nothing but what? Case 5 will be the inspection method, ma. We will do it as. Which is nothing but inspection method means what, ma? Simply we will go with the concepts of the different strategies. So, that I will inspection means by seeing the differential equation, you will just go what I can say that if I multiply 1 by y square, whether it is giving that or not, you will check it out. Nothing more complication here. Nothing more complicated here. Clear now? Am I right or not? Yeah. So now let me take the problem based upon these analysis. So let me take these criteria. Yeah. So take an example. This is the part of your a non-exact equation. See, exact directly you can do it as dou m by dou y is equal to dou n by dou x. If it is exact, then the solution will be what, ma? Integral m where y as a constant, integral n where the terms not containing x, you people have to do it as. That is how you have to solve it as. If it is a non-exact, then you have to concentrate these 5 different methods. Okay, yeah. In that, first let me take the first problem based upon this, so that you will have an idea. Find the integrating factor. Find the integrating factor of y power 4 plus 2y into dx plus xy cube plus 2y power 4 minus 4x into dy, which is equal to 0. For this you have to get the integrating factor. Yeah. First you have to concentrate what, ma? See, this you take it as m and this you take it as what, ma? N dx. So they directly asked me the integrating factor. So hence if they are asking the integrating factor means it is not a exact differential equation. It is not exact differential equation. So now if you understand this, the integrating factor, there are 4 cases I just given you, and the last case will be the inspection method. The first case will be what, ma? The first case will be what? You need to check it out whether this will be applicable for which case. See, the first case, all the terms of m and n should be the same degree. Is it? No. Is it? No, because this you are having what, ma? This is 4, this is 1 will be there. So it is not possible for case 1. Next case 2. Case 2 will be what, ma? Y into f of x comma y dx plus x into g of y comma dy will be the next case. So it is not applicable. Then directly you can tell this that problem is applicable either this case 3 and case 4. Then that too also particularly whether this is applicable for case 3 or case 4, you need to do it as. So what I told, the terms containing m is more or the terms containing n is more, that you have to check it out. So if you check it here, the terms of n will be more, so hence you have to apply what, ma? Case 4, that is dou n by dou x minus dou m by dou y by m is equal to g of y. So this if you are having that g of y, then your integrating factor will be what, ma? Integrating factor will be what? E to the power of integral g of y into dy. You people have to do it as. Clear, ma? Clear or not? Yeah, that is what the particular strategy here. So try to solve that. So what you will get it as here? Yeah. So first let me calculate dou m by dou y ma. What is your dou m by dou y? Dou m by dou y is nothing but what ma? 4y cube plus 2 is the dou m by dou y. Then dou m by dou x. Dou m by dou x is what? Y cube minus 4. Dou m by dou x is y cube minus 4. So now the terms containing n is more. So hence you have to take it as what ma? Case 4. So what is your case 4? What is your case 4? Dou m by dou x minus dou m by, sorry, this is dou n mama. Yeah, dou n by dou x minus dou m by dou y divided by m. Am I right or not? This is case 4. Yes or no? Yeah. Just try to analyze and just try to substitute these values. What is your dou n by dou x? Dou n by dou x is what ma? Y cube minus 4 minus dou m by dou y is 4y cube plus 2 divided by my m value. M value will be what ma? Y power 4 plus 2y. Just simply see it. All the functions it is in the form of your y only. So that I have to consider it as what? Either constant or we can take it as what? G of y also. Am I right or not? So just simplify this. You will have it as what? Y cube minus 4 minus 4y cube minus 2 divided by y power 4 plus 2y will be there. So y cube minus 4y cube. You will have it as what? You will have it as what? Minus 3y cube. So you will get as what? Minus 3y cube minus 6 divided by y power 4 plus 2y will be there. Yeah. What I will do is, I will just make it as a 3 as a minus 3 as a common in the numerator ma. Minus 3 if I take it as a common, you will have it as what? Y cube plus 2 will be there. Similarly, in the denominator what I will do is, I will take y as a common. So I will have it as what? Y cube plus 2 will be there. So now what I will have? This 2 will get cancelled. You will have it as what? This value will be what ma? This value will be what? Minus 3 by y will be there. So now this I used to take it as what? This will be what ma? G of y. If you are having constant, you just make it as what? That as a constant. So this is my G of y. Am I correct or not? Yes? Yeah. So now if it is that, then what is my integrating factor? Your integrating factor will be what ma? E to the power of integral G of y into dy. So what is that integrating factor? So substitute that in this case. So e to the power of integral G of y means what ma? Minus 3 by y into dy. Minus 3 is a constant. So for 1 by y, integration will be log y ma. So that is directly I can do it as e to the power of minus 3 into 1 by y, integration will be what ma? Log y. Yeah, again this 3 if I take it as, I will have it as what? E to the power of log y power minus 3. Am I correct or not? Yes or no? Yeah, so this exponential log term will get cancelled. You will have it as what? Y power minus 3. That y power minus 3 I can do it as what? Y power minus 3 I can do it as what ma? I can take it as what? 1 by y cube. So this is the integrating factor for the corresponding that one. Suppose, yeah, this is how you solved the part of your integrating factor ma. Suppose if I ask you the solution for this differential equation. As you know that this is a non-exact differential equation. So non-exact differential equation means what ma? Dou m by dou x is equal, sorry, dou m by dou y is equal to dou n by dou x. Is not equivalent to that. So hence that non-exact differential equation you people have to convert into the exact equation by taking the integrating factor. So what is the meaning for this is the overall equation, whatever the equation they had given in the problem, that equation you have to multiply with respect to what ma? That equation you people have to multiply with respect to what? 1 by y cube, because your 1 by y cube will be what ma? Your integrating factor, so that non-exact differential equation is converted into exact differential equation. So can you try this? We will get the solution for this. So I will just extend this problem. Am I right or not? So what's the differential equation here they had given? The solution also I am finding here. Am I right or not? The solution for this, so that if you are having that particular thing, the next problems will be very easy in manner. Okay, for first problem I will do it as, for the next of the things you have to get the solution. Yeah. So what is the differential equation here? Y power 4 plus 2y into dx plus xy cube plus 2y power 4 minus 4x into dy, which is equivalent to 0. So this is non-exact differential equation. This will be converted with respect to your integrating factor. My integrating factor will be what ma? 1 by y cube. So this is non-exact differential equation. NEDE means non-exact differential equation ma. Okay. Yeah. So that will be multiplied with respect to this one. So if I multiply, what I will get as here? 1 by y cube into y power 4 plus 2y will be there into dx plus 1 by y cube into xy cube plus 2y power 4 minus 4x into dy is equal to 0. Here just simplify it as, you will have it as what? Y plus 2 by y square into dx plus x plus 2y minus 4x by y cube into dy is equal to 0. So now the equation what I got it as here, the equation will be this. Am I correct? Yeah, this is the equation ma. So what I will do is, so now this is your m and this is your n ma. So let me check with cross verify whether it is the exact differential equation or not. Check it out. So what is my dou m by dou y? Dou m by dou y is nothing but what ma? This is 1 for y power 2, that is y square. You will have the differentiation. So come on, do it as. Come on, check it out. For 1 by y square ma, differentiation is what? Yes? Yeah. So what is the differentiation for this ma? Dou m by dou y, which is nothing but what? Y plus 1 by y square. So differentiation will be what ma? Minus 2 by y cube will be there. So minus 2 into 2 will have minus 4. So that is 1 minus 4 by what? Y cube will be there. So this is dou m by dou y. Next dou m by dou x. Dou m by dou x is nothing but what ma? For x 1 will be there. Then for this x you will have it as what? 1 minus 4 by y cube. So dou m by dou y. See, now it is satisfies dou m by dou y is equal to dou m by dou x or not? Yes or no? So now this is your exact differential equation or not ma? Yeah, again you will go with respect to what ma? The solution for that. Am I right or not? You can have it the solution. Integral m dx, where you need to treat y as a constant. So see that solution. What do people have it as? Yeah, integral m dx. So this is m and this is yet. So integral m dx. So that is 1 plus 2 by y square into dx plus what? Plus terms not containing x mod. Terms not containing x means what? This is having, this is having. Only this it doesn't have it. So 2y into dy, which is equivalent to what? C, constant. Yeah. So this overall will be what? My constant only na. Yeah. Y plus 2 by y square is my constant, which is multiplied with x plus with respect to this one. So 2 into y square by 2 is equivalent to constant. So again that 2 will get cancelled. Again this 2 will get cancelled ma. Yeah. Finally the solution for this is what? Finally the solution is nothing but what? xy plus 2x by y square plus y square is equivalent to C. This is the solution. This is the solution for the corresponding exact differential equation. That is how you people have to solve the problem based upon this analysis. Clear now? Understanding what I'm saying? Understanding now? Yeah, that is how you people have to do the analysis now. Okay? Yeah. Next problem. Solve y into 1 minus xy dx minus x into 1 plus xy dy, which is equivalent to 0. This is that one. So now check it out. This will be applicable for what ma? Case 2 or not? So y into f of x comma y dx plus x into g of x comma y dy. So this will be applicable for what? For understanding, I am just making this criteria. So this is case 2. So in that case 2, what I have to do it as, my integrating factor will be what ma? What is the integrating factor? 1 by mx minus ny. So this will be your m and this will be what ma? Your n will be there. So what is that? 1 by m will be what? M is nothing but what ma? So y into 1 minus xy into x is what? Mx minus n into what? So this is n. N we are having what? Minus x into 1 plus xy again, which is multiplied with what ma? Y will be there. So now if I multiply this, if I do this, what I get as here 1 by, I'm just multiplying ma here xy minus x square y. Yes or no? Is there any problem? Yeah, x, this is, sorry, this is xy and x square y square ma. Yeah, minus of minus plus xy, again you will have it as what? Plus x square y square you will have it as. So check it out. So these two will get cancelled. You will have it as what? 1 by 2xy is the integrating factor. Am I right or not? Am I right or not? Yeah. So this is my integrating factor. If I want to get the solution, so I need to multiply that equation with respect to 1 by 2xy. See here, instead of taking that 1 by 2xy, our integrating factor will be what? 1 by xy also. That constant doesn't make any impact. Okay. So again, one more multiplication of that 1 by 2. So integrating factor is either 1 by 2xy or 1 by xy also. You can do it as. That is nothing more complication here. Yeah. So if I multiply that, suppose if I take this has equation 1, so multiply equation 1 with what? Integrating factor 1 by xy. That I already told you more. So that 1 by 2, that doesn't affect any criteria. Okay, yeah, if I multiply this, what will get us here? Check it out. So 1 by xy into y into 1 minus xy into dx minus 1 by xy into x into 1 plus xy into dy, which is equivalent to 0. So if I do this, what will get us here? Check it out, ma. This y will get cancelled and this x will get cancelled. What do people have it as? 1 minus xy by x into dx minus of 1 plus xy by y into dy, which is equivalent to 0. Yes? Yeah. Now you can cross verify it as by default it is what? The exact differential equation. Okay, this is now exact differential equation. This is your exact differential equation. If you want, you can cross verify it as. That is not a big deal. So now the solution for this is what? What is the solution for this? Integral mdx plus ndy. Integral mdx plus ndy. So where mdx plus ndy means what? Where m you have to consider it as what? Yeah, what is the solution? You people have it as you need to treat y as a constant here. Am I correct or not? So 1 by x will be what? So 1 by x minus that x will get cancelled. You will have it as what? Minus y into dx plus what? Integral terms not containing x. So you will have it as what? Only minus 1 by y will be there into dy is equivalent to constant. So what will be the solution for this? What will be the solution for that? Yeah, which is nothing but what? 1 by x will be what? Log x minus you will have it as what? Xy minus this one. Again you will have it as log y, which is equivalent to constant. So again, if you want some more simplification, log x minus log y will be what? Log of x by y. So log of x by y minus xy, which is equivalent to c. So this is the part of that one. Okay. Yeah. This is the answer for that one. So likewise, you people have to solve the problems based upon this this method. Clear na? Yeah. So this is about this session. In the next session, we will start with some more problems if it required. Otherwise, we will go with the another method which is called as the inspection method. Okay. Yeah. Thank you.